Okay, we are going to go over comparing average rates of change and comparing square root functions. This is exemplified in your textbook on page 546 if you want to follow along. So this is how the book does it. I'm going to do it a little bit different, and I am going to start right here with this section. And I have a formula. The formula is V of D equals the square root of 2 times G times 1. Now, V is velocity, and D is distance, and G is the number of meters per second. Okay, so that's like time. In this case, our time is right here. Okay, so 1.6 meters per second. So every time you see G, you're going to put in 1.6. So if you come down here, it says, and I'm going to putting this as step 1 here. So I have my formula, and I've replaced the G with 1.6, and they want us to use these coordinates right here. So I'm using 0 and 10. So I only have to put in for 0 up here. So I put in 0, so V of 0 equals the square root of 2 times 1.6, which is from right here, times 0. Well, anything times 0 is 0, so we have 0. So when the distance is 0, then the y value is going to be 0. And now we're going to do it for the 10. So we put the 10 in, V of 10 equals the square root of 2 times 1.6, got that from right here, times 10. Okay, 2 times 1.6 is 3.2, times 10 is 32, so I have the square root of 32. And if you put that into a calculator, you get approximately 5.7. So with that, I have this equation I have this coordinate right here, 10 and 5.7. Okay, the other coordinates would have been 0, 0. So coming over here to step 2, which is their step 1, I'm going to use the coordinates 0, 0 and 10, 14 because they gave that to us. And I'm going to put it into the distance formula. So I'm sure you remember the rate of change is y2 minus y1 over x2 minus x1. Okay, I have 0, 0 and 10, 14. So 14 minus 0 on the y's, 10 minus 0 on the x's, and I end up with 1.4. Okay, so that's the average rate of change for the Earth. Then I'm going to do the same thing for the moon, and I'm using this coordinate down here and the 0, 0. So 0, 0 and 10, comma 5.7. So again, I have my y's on top, 5.7 minus 0 on top, over 10 minus 0 on the bottom gives me 0.57. And so this is the rate of change for the moon. So then you can tell down here, it tells you that from 0 to 10 meters, the velocity of a free-falling object increases at an average rate of about 1.4 meters per second on Earth and about 0.57 meters per second on the moon.